All right, we're going to take you through the steps to evaluate the value of each of these without the use of a calculator. And these are not whole numbers, so put them into the hard category. You need kind of a better strategy to figure these out. And we've got 4 problems, each one's slightly different. And each of these are in log form. And so this first step is just kind of the starting problem. And we're going to figure out the answer to each of these, the amount that it's equal to. And so think of these as equal to some unknown value, and we're going to call that x for now. And in each case, the answer to these, just so we have something in that place, is going to be x. And then each of these, the first step is going to be to convert it from log form into exponent form. And to do that here, the 9 represents the base, so this is going to be 9 to the power of x equal to 27. So this is now in exponent form. And that's not a whole number. So x is somewhere in between 1 and 2. And to find exactly how much, we're going to change both of these numbers. We're going to kind of reduce them, so to speak. We can substitute 3 squared. That represents the 9, which is to the power of x. And then 3 cubed represents the 27. And these have to be the same. So the big 3 here, that's the base. If those are the same, we can move forward here. So we can't change 1 into 9 and the other into 3. It can't mismatch like that. So this is a substitute step. All right, now next what we're going to do is do a simplifying here. So that we're going to simplify this exponents. When we have a situation like this, the 2 and the x, in this case, the exponent rule is to multiply those, making the next step 3 to the 2x equals 3 to the third. So this is a exponent rules, or just a simplify. And we need one more row here. So let's get this row. All right, exponent rules. And now what's true about this is, since these are both base 3, that if these are to be equal, then their exponents must be equal. And we're going to start, to finish this off, we're going to start a side problem here whereby the exponents must be the same, meaning that 2x must be equal to 3. Solve for x, meaning that we'll divide by 2. So x is 3 over 2, or 1.5 if you will. And so that's done. So those are the steps that we're going to follow to evaluate these. And I'm going to run through the next 3 in a similar way. They differ slightly. So let's go ahead and do the same steps here. So this will be 25 to the power of x equals 1 over 5. And both of those are base 5 numbers. 25 is 5 squared. And 1 over 5 is 5 to the negative first power. We have 5 to the 2x equals 5 to the negative first. And like before, we're going to compare 2x equals negative 1. X is negative half. So that's the value of this logarithm. That's what x was representing as the answer to this. Next, exponent form. All right, these are both base 2, so 16 is 2 to the 4th. And 32 is 2 to the 5th. Now the square root represents the 1/2 power, so in order to do exponent rules, we're going to substitute out the square root for the equivalent exponent.